All right, yeah, so I'll be talking about like simplifying DevOps with SlackBots. So a bit about myself. I do data science at Salesforce Einstein, and before that I'd done an information management and systems master's degree at Berkeley. So the agenda for the day, I'll do a quick sort of intro into what is Salesforce Einstein for those who are curious. Then we'll do sort of a short how we can sort of build a simple SlackBot using Scala. And also I'll talk a bit of why we've decided to go the route of using bots in DevOps with a few use cases. So yeah, to start, introduction to Salesforce Einstein. So the first thing for those most of us who are engineers or we don't know what AI is, I'll do it's sort of a simple AI 101. So the sort of in AI or machine learning, there's three simple things that you need to, that are sort of the fundamental basics of everything. The first one is the response or label, which is what are you trying to predict, whether it's somebody who is likely to convert to a lead, whether an email is spam, or whether a picture is a human or is a car or something else. Then the second most important thing is what are called features or predictors. And these are the factors that you sort of likely to predict the response that you want to try. So let's say you want to predict whether somebody is a good sales lead. It could be the industry, the zip code where they live, or whatever company they work for. Then the third most important thing is it's called a model. A model is a statistical, sort of human world representation of which sort of correlates or relates the features to the response that you're trying to predict. So it can be very simple, like a simple mathematical equation, which is y is equal to a plus b. The likelihood for this person to predict is their age times 0.5 plus their salary times 0. Something. Or it could be something very complex, I am sure some of you have heard the buzzwords convoluted neural networks, deep learning, and stuff like that. So what we are doing at Salesforce and why we're excited about Salesforce Einstein is we want to build the world's smartest CRM. And Salesforce is a big company which has a lot of use cases, which is quite different from most of the other companies that are around there. Because usually it's you want to build an app for a simple one use case. Let's say you want to recommend people products they should buy. So with Salesforce, it's quite different. We have all these clouds, all are totally different. They have different use cases. And also inside of all those use cases, the customers themselves are very different. So what we want to do is make sort of embed artificial intelligence to Salesforce so that everybody, even without a machine learning PhD, can be able to, leverage their data to make better relationships with their customers. So for us to do this, we had to build sort of an automated machine learning services architecture, which consists of the interface that people talk to with the Salesforce. Then you also in terms of machine learning, there are a bunch of steps that you need to do. First, you need to get the data, which we call data pooling. Then you do data preparation, which is you now have this data. How do you make it into the features and predictors that I talked about? Then you also want to build, do the actual machine learning, which is sort of building a predictive model and actually making the predictions, which is called scoring. Then also having a way to sort of surface your predictions back to the customers. And all this you need to do it in a very smart way with some model management and scheduling and also some monitoring services. So this is sort of enough of some of the tools that we are using, and I think no surprise is why we have Scala there. So for us to scale this, imagine for Salesforce, that architecture we have hundreds, thousands of customers, just to go back. So we are sort of building simple, sort of hundred thousands of simple architectures for each and every one of our customers. So we want to be able to scale this. So for us to do this, we had to think of ways to really do it in smart ways. First, smart allocation of resources. We can't just spool up resources willy-nilly. We have to think about who's the customer, what is their use case, how much data do they have, and what's sort of the impact to their own system if we deploy this service. Then you also have to we did it a couple of ways, generic, sort of just grouping them by big, small, or medium. But we also thought of we are data scientists, we could be smarter. We could also build models that predict usage of resources and and allocate it based on sort of like build another predictive model. Then on top of that, like if you're a DevOps, if you're into DevOps, there are two things. It's sort of like system administration and agile development. But in terms of all of this, what's important is you want self-healing processes. You don't want anybody waking up in the middle of the night to fix stuff. So we had to sort of like think of like what's the best ways to do self-healing, whether it's just like if it fails, we increase resources, how do we notify people, or like what's the simplest way for people to like, fix stuff. So we thought like bots would be sort of like a simple way and like very efficient for what we're trying to do. So now I'm gonna sort of like show like, we're sort of like building a simple SlackBot using Scala. So the basic pieces, like one of them is like we use Akka for those, we don't, so like what is Akka? Akka is a simple toolkit that allows us to build highly concurrent, distributed and resilient message-driven applications. I think the keyword is like message-driven. So it consists of like actors and which allow asynchronous non-blocking operations. And also it's very lightweight and event-driven. And also like another thing, the next thing is like fault tolerance. It allows like us to sort of like crash if one actor fails, but still like not affect the whole system. Then also the other third point, the third part is like the Akka HTTP, which allows us to expose these actors to the web. Because like if you have multiple like sort of like services, you're gonna have to talk with them over APIs, and the Akka HTTP is like a very simple and like efficient way of doing this. Then also, then another basic piece is like a lot of like what of services you're gonna talk to is gonna be through API. So you need very intelligent, or very functional JSON parsers to like receive data from across multiple services. Because you're not working probably with one service, you need to be able to pass data from whatever service or whatever resource that you're gonna do. Then sort of like final pieces, but the most important is like we use the Scala, Scala C and like the Scala C module for Slack and SlackBots. Why did we use the Scala C one? It's very easy to set up, as I'll show. Then also it's Akka based. Then why did we choose Slack? I think if you've used Slack, it has like multiple rich integrations from across multiple services, from whatever you can think of, you can almost certainly find an integration with it. Then also it's a real-time API. Then other than just like it being great for building bots, it's also a great communication channel for the team as a whole. So you can sort of like leverage bots inside them, but also be able to use it for your normal day-to-day processes. So using Scala C, the Scala C module is very simple. Like the first thing, what you need, you define sort of like your main module, which is a bot runner, which will sort of like initiate the app. And it consists like, as you can see, like the system where you initialize the actor system, then an event pass, then you create the bot using the Scala bot ADA, and what's called the bots bundle, which I'll show next. Then like if you're gonna use an actor system, you also need to think of like you also need to implement a shutdown hook, so that like after it had done something, you need to shut down and close the actor. Then the next component is what I talked about, is the bots bundle, where you define, I think, as I said, like you're trying to integrate multiple things. So with the bots bundle, you just like define which applications, and so that you can sort of like separate them across whatever you're trying to do. So we can have one bot for AWS, you can have another bot for Sumo Logic, another one for Chef, or another one for just chat. So that like if you decide to add an integration, it's very easy. If you decide to take one off, you just like stop calling that, and you don't have to like sort of like change your system in a lot of ways. So so example of like, let's say you want to build a chef bot, like using the Scala C, it's quite easy. What you only need to do is like implement two things, which is one, sort of like the help method, which will like sort of like if you're gonna expose something to users, they want to know like what that thing is doing. So the help, a method will sort of is where you define what the bot is gonna do, and like what are the expected actions and what are the expected responses. Then the second thing that you're gonna need to define is the act, which is an actor, which will tell the system like which defines the behavior that it's supposed to do when it receives a command. So like sort of like continuing implementing our chef bot. So let's say I want to do, let's say, chef knife job list, which is sort of like list the jobs that are there for chef. You can, using like what you call it, pattern matching, you can easily do that. Then sort of like implement using the get job list, which is like the method which you do whatever you need to do. And we can do it for another command, let's say, using against pattern matching. You can do case command, chef, job, start, and etc. for like multiple jobs. Then the last method is, I said, like the def, which will define like what you call it, what sort of like will give the user the expected input of how they want to use the system. And we can do this also for what you call it, for Jira, create another bot, define a bunch of actions and whatever what you need to do. And you can also go more adventurous. I think this is one of the stuff that we've been using is like we've implemented so that you can do like code reviews within like the same channels that you're using. So let's say I want to push a code review, which is usually for trivial tasks, let's say my code there. I can just like within the same sort of channel that people communicate, I can ask for a code review and people, without having to like send them emails, they can like, and easily they can sort of like look at it and sort of respond to the bot and say, oh, looks good to me, this, the code review number. Then we continue acting until like somebody says, oh, the minimum number of requirements are set, then my code is reviewed and it gets pushed into production. So like, then we also have implemented the bots for like multiple other things from Chef, Storm, Azkaban, Jira, Datadog, Kronos, Sumo Logic, or even like cow train alerts and like food catering. So probably another question that you might be wondering is like, why SlackBots in terms of versus like normal scripts? Because like, I'm sure like every like DevOps or like every engineer, your ultimate goal is to automate things and probably have scripts for this. But so why use SlackBots versus just like having scripts? I think for us, like one of the biggest things that we've seen is like we have a single source of information. You don't have to check multiple emails, like within the same communications channels that you're using with people is where you'll get like, you can interact with bot and automatically do your actions or like run jobs from there without having to like either log on to a laptop or log on to the service itself. Then also, what's cool about it is like actionable insights. You get a message saying something is broken and you can act on it in the same channel, which is different from like having it, like say you get a PagerDuty notification, then you have to like move away from, then you have to like log on to something. Then also in terms of like, since we have like multiple companies, multiple systems that we are running, mobility is a key issue. People can run jobs from the train. People can fix stuff from wherever in the plane or at home, which makes us, sort of like our life easier, or which sort of like helps us be more productive. Then also in terms of visibility, in the same channel, we can sort of see who has done what, or like what needs to be done, so that like it sort of like helps everybody, not just like have one person who's dedicated for, let's say, for a week in terms of fixing things. Then also like another cool thing, another like important point, bots are very cool. So yeah, try, yeah. So sort of like just to wrap it, I want to leave a couple of minutes for sort of like key takeaways. Yes, automate steps as much as possible and figure out like what's the best way to like sort of spool up software and resources. And I think what we have seen using SlackBots, what you call it, for us is like we have moved from having sort of like, I'm a data scientist, but like I'm now able to do some of the DevOps operations that I was previously not able to do. So it moves away from having DevOps as a dedicated team, but sort of as a culture for the team, like across data scientists, what you call it, software engineers. Then also like if you design for reuse, you can also like sort of just simply move one bot and just like change the actions for what you call it, to implement another action, another functionality. Then one last quote, it's quote from this guy, Alexander. Andre, he said, DevOps is dead, long live DevOps. But like, I think the point here being, DevOps should not be like sort of like a function dedicated to people, but also like try and figure out like what's the ways we can use like like for us, bots so that we can sort of like help spool out resources and also be agile in terms of our operations. With that, if you're curious, this is Salesforce Einstein. We have some of the things that we're working on across like Heroku, Prediction.io, and MetaMind. And if you're interested, as usual, a recruiting note, like you can send an email to einsteinrecruiting@salesforce.com. And with that, thank you. I'll leave. I'll be open for questions.
I'm just curious, did you guys implement any ACLs? And if you did, kind of how did you look at doing them?
Can you?
Access controls in terms of like who can do a deploy?
Yeah, definitely. I think it's because we sort of like it's our what you call it, Slack users are sort of like embedded with what you call it, with our Active Directory. We can easily like see like who the person is and like what are some of the privileges that they can have. So before we sort of like send it to a service, we can check against the what you call it, our Active Directory in terms of like the permissions that they have. Cool. All right. Thank you.